Right, we have a question here in front of us. Two snow-covered peaks are at elevations of 862 meters and 741 meters above the valley between them. If a skier starts from rest at the higher peak and just coasted down without exerting any effort, at what speed would he arrive at the lower peak? And we proceed to look at the solution to this problem. Right, so the solution is as follows. Right, so we analyze this solution together. Right, in looking at this solution, there are a couple of things we need to consider. And we must look at the fact that we're going to use energy principles. But we must first understand that work done by non-conservative forces equals the change in the potential energy plus the change in the kinetic energy of the system. Right, because at this point there is no effort and we understand there's no friction, and therefore it means that we have mgh, which is the potential energy final, minus mgh initial plus half mvf squared minus half mv initial squared, like so. So what do we get here? So now, because we have that it's from rest, so the initial velocity becomes 0 meters per second. And if the initial velocity is 0 meters per second, it means therefore we have mg hf minus mgh initial plus half mvf squared. This term becomes 0. Right, we divide through by the mass, and we multiply through by 2, and we factorize after transposing these terms to other sides. So we have 2g into, so this is going to be h initial minus h final, like so. And with that said, this is equal to vf. And therefore, this becomes the final velocity. Right, so hence, what do we get? Hence, it means that the final velocity equals the square root of twice into 9.8 meters per second squared. Right, obviously it's going to be skiing down, so the initial height is 862 meters minus the final height, which is 741, like so, and which means that the final velocity is actually 48.70 meters per second. So this is going to be the speed at which it's going to reach, because that is the question. At what speed? So direction is not important, it's just the speed, and therefore the speed at which it's going to reach is exactly that one. So it's exactly 48.70 meters per second. Right. There is also an alternative way to look at the question. Right, so in other words, alternatively, another student can look at this question differently. Another student can look at this question and say, what do we have? So we have mechanical energy. Mechanical energy at the top must equal mechanical energy at the bottom. Right, with that said, it means now at the top, when this guy is beginning, there are two forms of energy. So we have the potential energy, plus also there is kinetic energy, although zero. Right, by the time it reaches the other top, there is a potential energy and also there is kinetic energy there at the top. So in other words, these are the energies at the top, and these are energies, if you like, at the bottom. Meaning, in the end here, what we have is the following. We have mgh initial plus half mv initial squared, which is mgh at this point final plus half mv final squared. So that at the end, what we're getting here is that at the initial point, at the starting point, the initial velocity is 0 meters per second. And that means therefore this term is going to vanish, leaving us with mgh initial equals mgh final plus half mvf squared. Divided through by m, the mass, because it's common here, there, and there. It's common, and then you multiply it through by the 2, etc., and factorize the g here. So that's going to be 2g into h initial. Right, into h initial minus h final, which equals vf squared. Which means that vf equals the square root of 2g. Right, let me just write this one up here. Right, which means what we're getting here, if we divide the board like this, right, so we cancel this. Which means V final becomes the square root of 2g into h initial minus h final. V final, 2 into 9.8. H initial 862 minus 741. Okay, so if you do everything here, use a calculator, you get 48.70 meters per second of speed, meaning at the time that it reaches here, the final velocity is going to be 48. And therefore, we are done solving this problem here. And most certainly, we have that. And so thanks everybody for your attention. And we are through with this solving this problem. And then we say goodbye to you.